Good afternoon, everyone. Thank you so much for joining us today. I'm Amber Mace. I'm the Executive Director of the California Council on Science and Technology, and I am delighted to present a whole panel of experts to talk about extreme heat today. First, let me tell you a little bit about the California Council on Science and Technology, and then I'm going to, and how we are thinking about disaster resilience. Then I'm going to turn it over to our moderator, and she will lead us into a conversation with our panelists. So we, as a nonprofit, nonpartisan organization, are focused on bringing science and technology advice from California's extensive network of expertise and research institutions to inform policy for the legislature, the executive branch, and the governor's office. We were created at the request of the legislature over 30 years ago to be a source of science and technology advice, and we have formal partnerships with academic and research institutions throughout California, including the University of California, the California State University, the community colleges, Stanford, Caltech, Department of Energy labs, including Berkeley Lab, Livermore Lab, Sandia, and SLAC, as well as NASA Jet Propulsion Lab and NASA Ames. We lean on this network as well as other academic and research institutions in California and beyond to make sure that policymakers in California have access to ready advice when needed. And we have recently been focusing in on disasters. And this is an area for us to lean into because we all know that California has had just an incredible run of intersecting disasters, most recently some mega fires, some heats, the COVID-19 pandemic, you name it. We're thinking about it. California is responding to it. And we want to make sure that California has access to the advice and support it needs to build resilience into the system. And so one of the ways we do this is through briefings like today. We also provide peer-reviewed reports and other convenings. And of course, we have our Science and Technology Policy Fellowship Program, where we place PhD scientists and engineers for a year of government service and leadership training into the legislature and the executive branch. And so today we are thinking about extreme heat, and we have a panel of experts from some of our partner institutions to talk to you about this topic. And it's timely because we are headed into the summer. And this is also a time for us to think about how, you know, all of these disasters that we've been facing as a society can be very disruptive to our work and lives. At the same time, they can present an opportunity for us, an opportunity to rethink how we move forward as a society, to recognize that science and technology innovations can be incredibly beneficial. At the same time, they can also disproportionately result in inequities for underserved populations. And so we're thinking about how we can shine a spotlight on technologies and science, including social and behavioral science, that improves resilience and sustainability for all Californians. And so today I'm delighted that we're talking about extreme heat because it has impacts across California's diverse populations. And it's an opportunity to think and talk about technologies that are in existence and that are under development that can help us reduce the harm that our diverse populations are experiencing. And so it is my pleasure to introduce Kate Gordon, and she is going to lead us as our moderator today. She is Governor Newsom's Senior Policy Advisor on Climate. She is the Director of the Governor's Office of Planning and Research. She is the Chair of California's Strategic Growth Council, and she is a recognized expert in the intersection between energy, climate, and the economy. And so it is my pleasure to turn it over to you, Kate, to take it away. Thank you so much.
Thanks so much, Amber, and thanks to CCST for inviting me to moderate this panel on this critically important issue with this amazing group of experts. You know, California, as you just heard, is already experiencing record high temperatures, a record number of extreme heat days. The 3 of the hottest months in California history were last year. This is only expected to worsen with climate change. And extreme heat is, you know, it's interesting. It's not the most often talked about climate impact, but it's actually the most dangerous from a human health and mortality perspective. Extreme heat causes, detrimental effects to public health. It causes financial and economic strain. It causes strain on our utility grid. It really is a significant issue for communities and for the state. And disadvantaged communities are disproportionately located in areas that experience the hottest temperatures and are particularly susceptible to those impacts. Those impacts include, heat island effects, heat-related illness, actual mortality, and lack of access to resources like green space. Just the existence of trees in a neighborhood is a huge part of a mitigation strategy for extreme heat. And there are reams upon reams of papers showing that lower income neighborhoods have fewer trees and fewer green spaces. So at the state level, we really recognize, and I think you actually will see this in the governor's budget plan that just came out on Friday, but we really recognize that heat is a serious impact that will affect all areas of California, some more than others, but certainly all of California, and that historically there hasn't been a coordinated state strategy or approach in addressing this issue. My office, the Office of Planning Research, which is home actually to the one statutorily created climate resilience piece of our government, which is the Integrated Climate Adaptation Resilience Program, or ICARP, we are working very closely with our partners at the Natural Resources Agency to fill this gap through an update to our state adaptation strategy this year, and also developing a state framework on extreme heat. We also know that if we can't measure the impacts, we can't manage them. And that's why the governor's California Comeback Plan budget released on Friday includes, finally, actual money to spend on a California climate assessment that will make a sustained investment in climate research and science that's foundational to implementing every one of our other carbon neutrality and resilience priorities. That assessment will be developed through a rigorous stakeholder engagement process and focus on turning science to action by looking at climate impacts by region, by sector, and doubling down on critical issues to the legislature, such as protecting public health and safety, reducing risk to vulnerable communities, and building economic stability in the face of climate change. So extreme heat is a really serious issue for us as a state. It's a serious issue for many regions across the state and for a number of communities, especially vulnerable communities. And, but there are knowledge gaps. There is research that needs to help fill those gaps and help us figure out which technologies we need to tackle these issues. How do we use data? How do we use technology? How do we think about those gaps? The three researchers here have deep expertise in this set of issues, ranging from measuring land surface temperatures and emissions to thermal energy technology to heat impacts on health and vulnerable populations. And I should say that Jisung Park is one of the panelists, is a co-researcher on a grant that is funded through the Strategic Growth Council's Climate Change Research Program. So we like to consider you part of our family. These experts are actively working to understand how extreme heat impacts California and also how we can more equitably mitigate this set of impacts. So I'm going to ask each of the panelists in turn to just give a quick, brief introduction of their expertise rather than doing the full bio for each of them, and also a specific challenge that each is working right now to address. So I'm going to start with Dr. Glynn Hulley from NASA Jet Propulsion Lab.
Hi there, everyone. It's great to be on the panel, and thanks for the invite from CCST. So I'm from the NASA Jet Propulsion Lab. I'm a research scientist there, where I mostly specialize in the thermal infrared remote sensing of the land surface. And in this, especially land surface temperatures retrieved from NASA satellites such as EcoStress, Landsat, and MODIS as well. And so I've been mostly using this satellite remote sensing imagery to look at things like urban climate trends, trends in extreme heat in cities, and then also quantifying the urban heat island effect. More recently, I've been working pretty closely with local decision makers in LA County, such as the Sustainability Office, Climate Resolve, and other groups like that, to try and quantify the effects of heat mitigation efforts that they've been implementing in the city. And then also trying to quantify the most vulnerable parts of cities within Southern California, such as LA County, for example. That's it, thanks.
Thanks so much, Dr. Hulley. We'll definitely come back to you on some of those points. I'm going to go next to Dr. Jisung Park from UCLA.
Great. Can everyone, can you hear me?
We need your video, but
oh,
yes,
no.
we can hear you.
This is the fail we were hoping to avoid.
We can hear you, so
can,
you could talk. Yeah, I'll go to Sumanjeet first and then come back to you, okay? I'm going to go to Dr. Sumanjeet Kaur from LBNL, and I'll come back to Dr. Park in a minute. Dr. Kaur?
Yeah. Thanks, Kate. Hi, everyone. I am a research scientist and leader of Thermal Energy Group at Lawrence Berkeley National Lab. I'm a material scientist by training, so what I'm doing for extreme heat is looking for material level solution, which could provide relief during such events. So I have 3 goals in mind while we are developing this material level solution. First, as Kate mentioned, needs to be economical so that it can help where help is needed the most, which is our most vulnerable communities and disadvantaged communities. And they should have 0 global warming impact, right? Because that is why we are here. So we should not create a solution which eventually becomes a part of the problem. And then they should be energy efficient. So I'm very excited to be here and looking forward to this.
Thank you so much, and definitely excited to dig in on some of those kind of how we figure out how to map those impacts. Dr. Park, are you back with us? Oh, Dr. Park.
Here we go.
Okay, there you are. Hello.
So sorry about that. I think that a year into COVID Zoom land that we would have figured this out. My apologies, everybody. So sorry about that. So my name is Jisung Park. I am an economist by training. Currently, I'm an assistant professor in public policy at UCLA. I'll try to keep this short since I've already eaten up so much of your time with the technical glitches, but suffice to say, most of my work examines what you might call the microeconomics of climate change. So think how climate change, and in my case in particular, extreme heat, manifests in our day-to-day lives, whether that's the effect of heat on learning or labor, or its implications for economic inequality. Just one quick point about what we're working on currently. We're trying to really figure out what heat means for our workers, whether that's people in construction and agriculture working outdoors, or even in indoor spaces, manufacturing, warehousing, et cetera, and whether that's how it manifests both in terms of productivity effects as well as potentially health and safety effects. So I'm really looking forward to being on this panel.
Thank you, and so glad we get to see you. And you guys all have your good backgrounds on too, which I'm very impressed. So first, let me say we're going to jump into some questions from me and also from folks who are in the audience. Let me ask those who are listening in to please submit your questions through the Q&A feature so that we have them. I know there are many of you out there who are not shy, so I'm expecting lots of questions. But let me start with, what probably is a very foundational question, but I think an important one, which is, what do you even mean when you say extreme heat? What is extreme heat? I could go to any of you, but I'll just go reverse order. I'll go to Dr. Park first.
Sure. So I guess why don't I start with, one way to answer that question would be to say that how you define extreme heat may depend on what you think in terms of the effects are. I'll let Dr. Hulley speak to how climatologists define extreme heat, but in the social sciences, some of the research that I'm familiar with suggests that it may actually be, heat at even lesser extremes than what you might typically think of as extreme appears to have an effect on our daily lives in ways that, if you take a microscope and look at the data, become clear. Hopefully we'll have time to dig into this in more detail later, Kate. But some of the research that I'm familiar with suggests that even temperatures of 80, 85 degrees Fahrenheit, 90 degrees Fahrenheit certainly can affect health, learning, labor productivity, what have you. And so I guess I'd start by saying, what extreme heat means depends on the context and what kind of effects we're thinking about.
That is a great point. And I should just say in work I did before coming to the state, I did some work in this area, and we first of all used Fahrenheit instead of Celsius because people don't understand Celsius in the United States. But also just your point about sort of humidity levels combined with heat levels are one of the things that's particularly dangerous. So you do have to think about all those factors together, as well as sort of how many extreme heat days you have and what types of activities folks are doing. So that's a really good point. Dr. Hulley, since Dr. Park punted to you, climatologist view on this?
Sure. Yeah, so Jisung had a good point there that extreme heat is not necessarily a set 95-degree Fahrenheit or 100-degree Fahrenheit temperature, but it largely depends on the time of year. So the way that we define it, so the consensus is that what you do is you take a running window of climatological mean temperatures around any given date during the year. And then what you do is you calculate a percentile off of that. So say 98th percentile of that temperature, any temperatures above that can be considered to be extreme heat. And so as Jisung said, you could be in early winter time period, January, February, and 80 degrees could be classified as an extreme heat day, for example. Whereas if you're during the summertime, it's likely more than 100 degrees. And then, you could have a day or two like that, but then usually we define a set or a string of days of three days and more that breach those thresholds as defined as a heat wave, which I think a lot of people are familiar with. And so 3 days or more that breach those thresholds we define as actual heat waves. And then we can do trends look at trends and changes in detected heat waves over time, and then sort of quantify the effects of extreme heat over time in ways like that.
Thanks, Dr. Hulley. And Dr. Kaur, I'm going to go to you, but I'm going to add to the question, actually, because we had a question come in from Assemblymember Luz Rivas about impacts of extreme heat. So let me ask you both sort of how do you think about how to define it, but also this question from the Assemblymember, which is how does extreme heat impact California and who's most at risk within California as we're thinking about this sort of how do we define it here, who does it most affect?
So thanks for the question. So yeah, I agree with both Jisung and Glynn on how do you define it. It depends upon the context, the number of days, what's the humidity level, how long that period is, when it is happening. And in terms of impact, I think the communities, which are low income communities, are most vulnerable to this kind of extreme heat event. And the impact can be as you mentioned in your introduction, the impact can be monetary, it can be health-wise, and it can be just a discomfort. People cannot do their work outside, so in productivity. So it has a wide range of impact.
That's perfect, thank you. And others can jump in. You don't have to wait for me. And I don't know, Dr. Park, you do a lot of work in this space, so I don't know if you want to add to that.
Yeah, sure. And I also don't want to steal Glynn's mic because maybe
I'm going to Glynn next, so you can. I promise I will give you all lots of time to say things. So go ahead.
I say this partly because I'm worried that I might keep going for too long. So a couple of things worth noting in terms of extreme heat and adaptation. There is a lot of evidence to suggest that people who live in places that historically don't experience as much heat on average, even during the summer months, appear to be, for whatever reason, less well adapted to any given heat event. So think of a 90-degree day, maybe somewhere, in maybe even in Fresno or Sacramento, not as big of a deal as say somewhere like the Bay Area. And this is true within California as well as across the country, whether that's in terms of the effect on mortality. So for example, a 90-degree day Fahrenheit appears to kill far more people in a place like San Francisco than a place like Fresno, in part because it seems the built infrastructure and a variety of other adaptations is a function of, depends on how many such days you experience on average during the year. And then there is some evidence to suggest that individuals acclimatize over time, right? So within a season, and that kind of gets to what Glynn was saying about, how unusual is a given temperature event for that season or month. That might be an important piece of it as well. And if I could just add one more thing.
Yeah, please.
We typically think a lot about how where you live affects your degree of exposure to extreme heat and possibly your adaptations to it, whether it's built infrastructure, what have you. But I might also posit that what you do right? For example, your occupation, what kind of job, right, you hold, and even, you know, how well endowed your school district is, for example. These kinds of dimensions, even within a geographic area, may alter how, right, a heat wave rolling through Los Angeles, how that actually is manifests or is felt by individuals varies along these many dimensions. And getting to your point earlier about, you know, what we don't yet know, you know, to speak on behalf of the, at least the social science research community, I think there's, you know, we've only, this is only the tip of the iceberg in terms of understanding the various dimensions of inequality, of how heat manifests as impacts on human well-being.
No, it's a really important point, and I think also, you know, something that my office has spent a lot of time looking at with COVID is the regional economic kind of diversity and lack of diversity in California. And there are regions that are overly dependent on occupations that are very susceptible to extreme heat. So it's sort of an interesting economic development issue where you've got sort of this whole set of people that you're depending on. And actually, I'm thinking right now about Arizona, because it's top of mind for another reason. But in Arizona, for instance, a lot of road construction has shifted to nighttime because of extreme heat impacts and increasing impacts. And that has all kinds of implications for the economy, for the workforce, and of course, there was the period when the planes didn't take off because of extreme heat. So really an important thing to think about, those connections with individuals and communities, and also with the economies of these places. You brought up sort of the point about how we're only just getting to know what this looks like. And I wanted to kind of dig in on that and on sort of projections. And this is where I'm going back to Dr. Hulley for a second. I mean, Dr. Hulley, so I don't know if this is a pet peeve for you. It is for me when people say, you know, climate impact projections are so uncertain, we don't know how to plan for them. And in the extreme heat world, we actually have a fair amount of understanding, am I right, about how to think about those projections, and even at a pretty granular level. Can you talk about that for a bit?
Sure, yeah. I've actually looked more at sort of historical trends. So looking back to in the past, so back to the, you know, post-World War II, 1940s, when we started taking extensive data, such as surface air temperature at various stations, which I'm sure you know, a lot of you know that there's a lot of NOAA stations out there that take a lot of surface data. And then looking at trends to the present day, and then using those trends to sort of project forward, and you know, as business as usual, as some people like to call it. And so I haven't actually used a lot of actual climate models to project that data forward, but we look historically and then and see, you know, assume that those trends will increase in the near future. And what we see is that we've been looking at sort of regionally. So, you know, California is such a diverse place, you know, topographically, climatologically, and also just with its demographics. And so we've looked at this extensively in the Southern California region to start with. And what we found is that there are very strong increases in the trends in extreme heat in terms of heat waves, both in their frequency, the duration, the intensity, and also the season length of the heat wave. So that the time from when a heat wave starts in the year to the last heat wave that we get in a given year. And those trends are more manifest in inland urban regions of Southern California. So think inland Empire in LA County, inland areas of San Diego. And those trends are most strongest and most intense in those regions. And that has a lot to do with, for example, the urban heat island effect is greatest in those areas that don't have the moderating influence from the coast. And then next are the urban coastal regions, which also have shown very strong trends in heat waves recently. And so, you know, we do expect those trends to increase, you know, without extensive heat mitigation efforts and you know, just curbing our emissions in general.
That's great. And we do have a couple of, some sort of foundational questions from the Q&A, but which I'll ask in a second. I did want to follow up on your last point there, you know, just about mitigation, what we can do to mitigate some of these impacts, because it, you know, as I think you said, and we sort of know from the science, many of these impacts are baked in for the next few decades. I mean, we have got a certain level of of certainty around what that looks like if we continue on our current pathway. But even if we, even if we shut that all off tomorrow, carbon stays in the atmosphere for a long time. These impacts are there for the time being. What kinds of strategies, and I'll maybe turn to you, Dr. Kaur, can we be starting to look at, and we'll talk more about this too, but what are some kind of available and emerging technologies to do something about this, given that, again, even if we turned off all of our carbon emitting industry tomorrow, which would have a whole host of other impacts on vulnerable communities, even if we did that, we would still have a fair amount of this baked in.
A very great question. And I'm sorry, this answer is going to be a bit long. So I will propose three kind of, solutions which we are looking at. When I say we, it is all the research community. So let's start with, the simple solution you have given about planting more trees. That's a very good, solution. So let's go beyond that. Let's just start, what is our state of the art right now? Let's look at our buildings. Let's talk about, let's say it's a very hot day, 90 degrees Fahrenheit, our roof, which are now all black, absorb all that energy. So our ambient temperature is 90 degrees Fahrenheit, but our roof is at 150 degrees Fahrenheit. Now you imagine, even though you have insulation, whatever, you will transfer that energy inside the building, you are increasing your cooling demand. So you are pumping up your AC now because you have to cool the building down. The simple solution for that would be, instead of absorbing all that heat, can we just reflect it? When the sun is shining the strongest, can we just make our buildings such that they don't become, the heat absorber? We just start reflecting them. So now people are looking into cool roof, so just having a good reflective coating on your roof, you can say, for example, if you're 90 degrees Fahrenheit in ambient temperature, your roof just stays closer to that, right? So you have made an impact by reducing your cooling energy demand. And that can go beyond roof. We can have cool walls, cool pavement. He was, Glynn was referring to urban heat island. That effect can be reduced if we have the whole infrastructure such that when we have such hot days, we are not absorbing that energy, we are reflecting. That's one. The second is so this is an example how we can just stay closer to the ambient temperature. Now the question is, can we do something? Can we cool down our surfaces while we are at 90 degrees Fahrenheit by passively? I'll give you an example. There's something called deep space cooling. Now this might sound a bit sci-fi, but hear me out. So, we know that the heat flows from high temperature to low temperature. When it's a hot day, everything is hot. So if I want to let the heat go away from my building, people have developed these panels, which you put it on your roof. And what they do is that not only they reflect all the solar radiation, they also radiate or emit in a wavelength where our atmosphere is transparent, between 8 to 13 micron. And our space is at 3 Kelvin in Fahrenheit, minus 450 Fahrenheit. So it is escaping our atmosphere. And they have shown, this is a group from Stanford, they have made a company, I'm going to put a link in the chat in a minute, so people can go and check it out. They have shown that if you have a panel, passive, sitting on your roof, you cool it down below the ambient condition by just placing it on your roof, then you can run water through it. It can assist your AC connected with HVAC, bring your cooling demand down. And they have simulated and shown that you can save up to 21% of energy consumption. That is contributing towards, mitigation. The third and the last is that we have been stuck with this vapor compression AC cooling for long. We have been trying to change the refrigerant, go to lower GWP, global warming potentials. What if we use materials which, when applied under certain condition, have temperature change? Let me give you an example. There is materials like natural rubber. If you stretch them, there's a temperature change. There's material when you apply potential against them, there's a temperature change. So these are called caloric materials, like elastocaloric, electrocaloric, magnetocaloric, depending on what external field you use. So the research has been ongoing into this solid state cooling. So when we talk about cooling centers, can we make cooling centers using that? And if you think about space conditioning, you want to provide comfort to the human, and we are cooling down the whole space. Can we just do this localized space conditioning, which are more energy efficient? Can it be as localized that someone can just put a jacket on and it is just, cool enough, and then you don't have the impact of extreme heat? So these are the different level of material level solutions which we are looking into, which can help us when these kind of extreme heat events happen.
Thank you. That was a great comprehensive answer. So I really appreciate that. And please do put that link in the chat. So much to follow up on there. It does strike me that that your first set of things, trees, cool roofs, urban greening, there's some of the cheapest solutions actually out there for dealing with adaptation and resilience. And it is something that, we're certainly looking at, but cities and counties, I think all over the place, do need to start thinking about really proactively, because they're not the huge, kind of billions of dollars of systems type things. They can be integrated pretty easily.
That's very correct. Especially something like as cool as just painting your roof cool. I mean,
Yep.
With this cooler colors, and it doesn't have to be just white. Now they're coming up with cool colored roofs, because aesthetic plays a role. I don't want to maybe go in a place where everything is white and glary, right? So yes, the aesthetic plays a role, but I think there is a need to bring these technologies into the market, and some incentive as a customer. To me, first, an awareness that if I put a cool roof, it will save me a utility bill, and secondly, some incentive, maybe in form of tax credit or something, which can help, more adoption of these kind of technologies.
So on that topic,
go ahead. Yeah, please, Dr.
Sorry, just on that topic, it's a great point there, is that a lot of people have asked me, the exact same question. And actually, I have a really good friend of mine in the San Fernando Valley. He used to have a black shingle roof.
Mm-hmm.
And I took a thermal camera from JPL over to measure the temperatures on a heat wave day. So we got up on the roof, measured the temperatures, and then he applied this cool roof paint that he just bought from Home Depot the next week. And we remeasured the temperatures on a very similar hot day, and they were about 30 degrees Fahrenheit cooler, the room temperatures. So there's a very, very dramatic difference in the temperatures by applying the cool surface. And then what he found was that he barely had to use his air conditioning that summertime. So there's a definite cooling potential and reducing utility bills. But then a lot of people again ask me, well, I'm renting, so my landlord's not going to let me paint the roof of my apartment or the pavement in the parking lot. And there's a large proportion of people renting in poorer neighborhoods in LA. So, how do we overcome that problem?
Well, and there's a couple of questions in the Q&A from the folks listening in that are on this issue. So I'll kind of throw them out there. And one is sort of, what materials are you talking about for cool pavement in particular? Cool roof, it sounds like painting is part of the materials answer, but there are also some materials that you talked about, Dr. Kaur, but also sort of when you're thinking cool walls, cool pavement, are there materials that are interesting that are being developed? Have you seen any cool technologies? And then also just the more kind of prosaic question of, cool roofs are not something that people talk to you about. When you call it an energy efficiency contractor, that they don't talk about it. So what are the ways that we could start thinking about kind of increasing knowledge and understanding on these issues? So materials and communications questions, really for anybody.
I'll take a first cut and then please jump in. I posted a link for the ongoing work at the national labs. There's the Oak Ridge National Lab and Lawrence Berkeley National Lab are being very active in this thing. So this cool roof materials are available in all the form and factor. Like Glynn said, you can buy a paint it up. It can be shingles, it can be tiles. And in terms of your second question, how we encourage, the same way we encourage the low E windows, right? I mean, people were just using single pane windows, but now everyone has double pane low E windows. So I think it has to be both push and pull. First, the awareness. People don't even know that something like this exists. And then the benefits of that. And then maybe some incentive from the state and federal government to use those new technologies.
Yeah, so I think that the cool pavements part is a little bit beyond the normal citizen because of just cost-wise. You know, there are a couple of companies implementing this cool seal technology, as they call it, and it's basically a type of paint emulsion, but there's a lot of work and background that's gone into, you know, optimizing the type of material and the color of it. You know, it can't be too white because then it's very reflective and glaring. And so, you know, there's a couple of projects currently going on in LA from the Bureau of Street Services where they're painting large neighborhoods and then trying to quantify the cooling effect. But just in terms of someone's roof, you know, that you can go to the Home Depot and there are cool reflective paints that you can just go and buy. They're a little bit more expensive than normal paints. I know MIT has just come up with this sort of 95% reflective,
yeah,
amazing super paint. You know, it is in the news
Cool.
recently. So, you know, we're definitely making a lot of progress.
Well, and one thing, and I'm going to come to you for in a second, Dr. Park, so keep that thought. One thing that also that we're trying to do at the state level, but I think a number of local governments are as well, is actually requiring our agencies to think about climate risk reduction when they are doing procurement or doing design build on different types of investments, which can start kind of down, like our Department of Transportation really thinking about materials for parts of the state that are going to experience extreme heat and and thinking about other paint and other materials. So I think there are ways to incentivize those decisions through things like procurement standards and through actually climate risk disclosure, which is a growing area of focus nationally and internationally. Dr. Park, you should weigh in on this. I also want you to weigh in on a question that came in from Tony Barboza, which is really digging in on the question about sort of where are we going to see these big impacts. So what areas within California are you most concerned that we're going to see increased heat-related illness, mortality, the labor productivity impacts that you're talking about, sort of really kind of getting specific about where we're seeing these impacts. So over to you.
Yeah, let me try my best. So just to start, I share everyone's enthusiasm about these new technologies, cool pavements, cool roofs, and the general sort of proposition that the state and the government should probably lead the private sector with the incentives necessary to develop these kinds of new technologies that can mitigate the effects of heat. I might just add, without over problematizing it, without fulfilling too many economist stereotypes, that there may be a reason why, despite the fact that something as simple as air conditioning has shown to be effective, and we should talk about the sort of greenhouse gas implications of air conditioning if we have time. But despite the fact that air conditioning is effective, and the fact that the United States on average is one of the most wealthy countries on the planet, we still have roughly 10% of the population who do not have access to home air conditioning. And there are many schools, by the way, that do not have classroom air conditioning or have not been able to upgrade, their facilities in such a way that would protect the students from the heat that we have baked into the system. So I would just add that in addition to the technical fixes, thinking about what is required to go from economic feasibility of the technology to widespread diffusion, especially in the sort of last mile pockets of the low income, right, disadvantaged populations who we know, we think to be more vulnerable to these effects. I just wanted to point that out, that part of the tech equation, the adoption piece is probably important. To your question about, where are the impacts going to be felt largest? I guess, let me start, if you don't mind, in terms of the sectors where we know heat to have effects, and then maybe go into the geography. We've known for a long time that heat has very significant health effects. So heat kills. In fact, you mentioned this at the outset, Kate. I think that heat is one of those threats that it's not as salient, right? It's if you can think of it more from a societal perspective as sort of like a death of 1,000 little cuts, right? Someone dying because of heat stress probably not going to make the news the same way a wildfire or a hurricane might, but you add up all those little cuts across society, the numbers actually are larger, certainly larger than any natural disasters, maybe even larger than other causes of mortality that we consider to be large, such as cancer or diabetes even. So health impacts we know to be large. They tend to be concentrated in the elderly and infants. But just in the last 5 or 6 years, we've learned so much more about the sort of more subtle effects of heat across different sectors of the economy. We know that heat can affect labor productivity. There's emerging evidence that heat affects workplace safety, and that's part of the project. That's part of the work that my team and I are currently doing in collaboration with the Division of Workers' Compensation in California. And there's also evidence to suggest that heat, slows the rate of learning and what economists call human capital accumulation. So these are just 3 of many potential impacts that we're aware of. Now, getting to the geography of this, I have to admit I'm still a relatively new transplant, geographically speaking, to California. I didn't grow up in California, so the rest of the panel is going to have to help me out if I leave any bits out. But just in terms of sort of the principles here, I think of impacts as a function mainly of two pieces. 1, the degree of exposure, and 2, the degree of vulnerability. Exposure is just a function of getting to the conversation earlier with Glynn about where we expect more extreme heat over the next, say, 3 or 4 decades, right? The heat that we've baked into the system, as you mentioned, Kate, regardless of what we do in terms of mitigation, greenhouse gas mitigation. But vulnerability is a little bit more complicated. And there, while there is evidence to suggest that places that are hotter on average tend to be better adapted, there's also evidence to suggest that within geographies, right, people, households whose head of household works in a more exposed occupation may be, right, more vulnerable. Lower income populations, possibly depending on the kind of housing stock, the age of the housing stock, may have less access, right, to air conditioning or other built infrastructure. We know that, within a given city, and you mentioned this earlier, Kate, access to green space and tree cover is highly correlated with income because it's such a localized amenity. So I think all of these sort of granular factors are going to have to be considered if we want to, pinpoint with a scalpel as opposed to a hacksaw who is going to see the largest effects, because it's going to vary so much, not only across geographies but also within. I hope that answers the question.
No, it's a great point, and I will keep coming back to the budget proposal because it's all we're thinking about right now. But one of the things that's in there is additional support for a project that my office has already started with some philanthropic support on mapping vulnerable communities across California, which really gets to this exact question. And with some types of impacts like wildfire, honestly, access to a vehicle is a big part of vulnerability. And with heat, it's a different set of things. We do know that Fresno, for instance, which is inland, to Dr. Hulley's point about being hotter inland, about 40% of the population makes less than $15 an hour. So there is a real overlap between areas of the state that are more likely to have extreme heat impacts and areas of the state with much lower incomes. And also there's an overlap with some of these high impact occupations like landscaping, for instance, and other outdoor occupations. We have so much more we could say. I did want to follow up on something you just said, and this is really for anyone, which is a question coming in from Laura Lynn Powell, which is really about air conditioning and your point, which was really good about schools. And it's absolutely true that there's schools all over this state that don't have HVAC at all, that don't have working HVAC systems. And let's just talk about air conditioning. I mean, any of you, it's not, as you said earlier, Dr. Kaur, not the most advanced technology in the world, doesn't even exist in some places, has GHG impacts. Are there better things out there? I mean, you talked about some of them already, but what can we think about in terms of next generation? What is the next thermostat of the air conditioning world that we could start thinking about?
Yeah, no, there are many cool things happening, right? Literally. So, just going back to Jisung's point, I do acknowledge that, in the schools where there is no HVAC, and yes, we should look into AC, but we should also explore what can we do beyond AC? Can it be cleaner, right? So just a context, it is expected that world is on track to add close to a 1.6 billion AC units by 2050, if you consider all the developing countries and everything. So that, imagine the impact of that on our climate. So we do have to come up with the solutions which are more cleaner and neater. So this is where I think the material research can really help, because so there's something called solid state. Right now we are doing this vapor compression. In solid state cooling, there is no GWP, there is no global warming potential of that. We are just taking a material. It is a property of the material to change temperature. And that change in temperature depends upon whether you stretch it, or you apply electric field, or you apply magnetic field, or you apply pressure. So people are making, I mean, ARPA-E, DOE are all looking towards these kind of solid state devices, which can say, condition a room. And they have shown to have, coefficient of performance is something which we use as a term to compare different thermal units, and they have shown to perform equally well like AC. And in terms of economics and cost, I think they're going to be competitive. So yes, so there are solutions out there, maybe not for tomorrow, but coming out soon, where people have started showing the field demonstration using those devices.
Dr. Hulley, did you want to jump in on this one?
Yeah, just quickly, Suman. So do you know the relative cost involved with devices like that relative to air conditioners, or that sort of is a big driver?
No, so that is a big part. They are working on this techno-econo analysis. They have already figured out the COP. So some electrocaloric devices can have a COP equivalent to AC units. So the part is all about what it takes. So that is what they are looking at.
Okay.
The economics of it, yes.
Yeah, I mean, air conditioning is a difficult topic because, while it obviously really helps in cooling down a home, there are a number of, detrimental effects such as anthropogenic heat emissions from the air conditioning systems themselves. And then also in the disadvantaged neighborhoods, a lot of people may have air conditioning, but they're reluctant to use it because they don't want to drive up their electrical costs for that month. And so I know the LA County is trying to install a lot of solar panels in these disadvantaged neighborhoods where they can, take advantage of more free forms of energy to be able to run air conditioners. At the same time, the solar panels actually cool down the house because they're more reflective than traditional tiles or other roofing materials. So in that regard, the LA County is also definitely trying to implement these type of heat mitigation measures in the most disadvantaged neighborhoods.
That's a great example, and I think Dr. Park was abducted from our call, but hopefully he will make it back. That is a great example, and it's funny because from a kind of a pure GHG perspective in terms of sort of renewable energy, rooftop solar is not actually as efficient as like utility scale solar, community solar, but from a kind of a roof cooling, an individual kind of home perspective, it has different benefits. So it's just an interesting thing to think about. Moving to other strategies outside of the building envelope, and kind of going back to some of the urban greening conversation we've been having, we have a question from Sydney Chamberlain from the Nature Conservancy, which I'll just read because it's a good question, hoping that you guys can say something on this. Who says urban greening and afforestation have a strong potential to help communities with extreme heat, including addressing equity concerns, as we just heard about, given the correlation between tree canopy cover and household income. While the state has programs and funding for tree planting, a challenge is tree maintenance. How would you recommend accelerating urban greening and afforestation efforts in light of this challenge? Are there greening strategies that utilize less resource-intensive vegetation? Sydney asks. So I'm wondering if any of you have a vegetation or urban greening bent, and you want to go to this question. And welcome back, Dr. Park. We missed you.
Oh man, I'm so sorry.
Well, now that you're back, do you want to talk about urban greening?
I had a point lined up about air conditioning.
Well, why don't you start with that, and we can come back to greening because we want to hear your point.
I apologize again. I mean, clearly I'm the most tech non-savvy of the group here. I guess I apologize. I didn't get to catch the rest of Dr. Kaur's comments, but I just wanted to clarify that when I mentioned air conditioning as sort of the last mile problem there, I didn't mean to suggest that air conditioning is necessarily the best adaptation strategy, but just to point to the fact that maybe, to steal kind of a COVID analogy, while we are thinking about vaccine development, we may also want to think about vaccine distribution. And given that climate, right, is a much slower moving challenge than COVID, we sort of, it's an opportunity to, in addition to thinking through tech development, thinking through the distribution, especially with an eye toward inequality and ability to pay, even for technologies that are available.
If I can add, that's a very good point, and I 100% agree with you. And also, we should not discard AC altogether, because there's a lot of research efforts ongoing in that field to reduce its GWP. We have moved from one refrigerant to another, and now we are finding the HFC alternatives. So yes, totally agree. And in the end, it's going to be a mix of different solutions, which will, take us across the line.
Exactly.
So we're not going to kill off the air conditioner just yet, is what I'm hearing. And this is something, we'll come back to trees in a second, but this is something, just from a policy perspective, one of the things I was honored to get to do was to chair the Citizen Oversight Board for Prop 39 before this current job. And that was the big slug of money from our tax system to energy efficiency in schools. And it was interesting because the policy was designed so the metric of success was reduction of GHGs. But if you're looking at a school that's never had an HVAC system and then you put one in, it automatically increases the GHGs of that school. So it was a very interesting sort of real world example of, we think we have this figured out over here with the metrics, but in fact, that doesn't work in all circumstances as the best metric of success. It's worse to be in a school with nothing, where people are, having severe health impacts because they have no heating or cooling, than it is to have a very efficient heating or cooling system. So it's just a really important, I think, reminder. Dr. Park, yeah.
Just piggyback one point onto that. In fairness to you and the rest of the folks working on that bill, at the time, my understanding is that and not to sort of toot my own horn in terms of the research that I've been involved in, but our understanding of what actually being able to quantify whether or not heat in the classroom is simply a nuisance, right, and sort of unpleasant, versus does it have a material, measurable impact on learning? That was something that we did not yet have the research for. And so this kind of gets back to your earlier point about, if you can't measure it, you can't measure the benefits of something against the costs of it. And so if it's only a cost, right, the deck is sort of stacked. And I would imagine that part of the intention of the kind of research that you were speaking to earlier, Kate, is to try to make sure that when we are assessing these various mitigation options, that we have, the best information available with regard to how heat affects, give me an outcome, how it affects that outcome differently for men versus women, elderly versus young, et cetera, et cetera.
That just opened up a whole bunch of questions for me, but we are running short on time. I will say, I didn't get a lot of jumping on the tree canopy question, but wondered if anyone had anything to say about that. And then I'm going to do a quick wrap up question. So how do we do better with tree canopy, with urban greening? What are some good strategies? How do we make it so it doesn't cost cities an enormous amount of money to maintain it? What's the plan?
I can quickly give a 2-sentence summary of LA anyway. So Mayor Eric Garcetti in LA just implemented his own sort of Green New Deal recently, where they plan to plant 90,000 trees in LA area. And so we've been working with the Climate Resolve group in LA using satellite imagery data from, it's called EcoStress on the International Space Station, provides 70-meter high-resolution land surface temperature data. And we take the average temperature throughout a summertime period over Los Angeles, and then use that to pinpoint neighborhoods and regions that would benefit from just planting more trees. And so they've been directly using that data to try and more optimize and pinpoint the best places to plant trees.
Smart.
The other thing with upkeep of these trees, obviously, planting them in urban areas, they, crack up the pavement and so forth. And a lot of, local councils will remove the trees because people are, suing because they're tripping over the, the broken pavement. And then what they're doing is they're not replacing those trees because of cost, right? And so that there's this constant fight to not only maintain, the effects of planting trees in the urban areas, but just to plant more trees as well. So.
It's a fascinating, a constant struggle. I like though, I like Dr. Hulley that you answered the question on how do you deal with the expense of maintaining trees by saying that we should get satellites. That's a good comparative.
Yeah, more satellites.
But it is absolutely true. The satellite technology is amazing even on things like chlorophyll levels of at this point of tree canopy. We are running out of time. Such an interesting conversation. I'm going to give each of you literally a sentence to tell me what are the gaps in the knowledge? What's the one thing you think we need to study more or know more about in this space? I'm going to go to you, Dr. Kaur, first.
Oh man, I was hoping you'd start at the other end.
Oh no, I did Dr. Kaur first. I didn't do you. I'm giving you time, Dr. Park.
Oh great, excellent.
Sumanjeet, you first.
Okay, Dr. Park is really excited, I can tell. So I think the gap for me is that we have to bring forward this new material level solutions which can provide, which can provide relief during these extreme heat events. And they need to be first low cost, highly energy efficient, and should have zero GWP. That is
a small ask. Thank you, though. That's awesome. Okay, Dr. Park, you had time to figure out your answer. Now it's to you.
Great. I guess I would say that figuring out what are the constraints, if any, between those who want to purchase adaptation technologies and individuals who can, right? So given technologies that we know to be effective, why is it that some individuals take this up and others do not? And is there a role for the state to play in facilitating that?
Perfect. And Dr. Hulley, last word.
In terms of data, I would say we need more high resolution surface air temperature data. So this is the air temperature that we feel as humans in the city. What we retrieve from satellites is actually the surface skin temperature. And so it's not quite the same, and it's very difficult for us to estimate what the air temperature is. And so what we need is better modeling, more high resolution satellite data, and together with that, we need more high resolution relative humidity fields at the same time so that we can estimate more fine scale heat indices in cities.
You guys are so true to your fields. I love it. So now you can go off and find out those things and talk to us about how to help you. I'm going to turn things back to Amber. Thank you all so much. You're just incredibly fascinating. Would love to keep talking about this, but I'm not allowed to. So going back to Amber.
I know. I wish we could keep the conversation going. Kate, you did a wonderful job moderating. It was great to hear all of your expertise from the team. Thank you so much for all of your contributions today. Thanks to all the attendees who asked great questions. I am so sorry we weren't able to get to many of them. There were so many good questions that came in. For those of you who want to revisit this will be posted, this link to the video will be posted on our website, as well as the one-pager that has contact information so you can follow up with the experts who you met today. And I want to thank our CCST team who made this possible. Really excellent conversation and so much knowledge. And I know that you all could have gone on for quite a while. So thank you, and more soon. Have a good day, everyone.
Thank you.
Thanks. Bye-bye.
Bye-bye.